When you look out at night up in the sky, you see countless stars lighting it up. Some of them are so far away that it takes thousands of years for their light to reach us. Others are close enough that we can call them neighbors. Among the thousands of stars close to us, there are many unique and fascinating ones that will blow your mind. Let's talk about some of them. Did you know that within just the 50 light-years radius around our solar system, there are around 1,400 stellar systems? We can call these our nearest neighbors. A good number of these stellar systems consist of more than one object. With that in mind, we can easily put the number of our stellar neighbors at more than 2,000. They are not all the same either. There is diversity beyond our imagination in our cosmic neighbors, from red dwarfs with dim luminosity to giants whose sheer scale can leave you stunned. There are wonders everywhere to behold. Talking about each one of the stars close to our solar system would take too long. So we will look at some of the more unique ones on our journey today. We will travel at a speed even faster than the speed of light to cover years of distance in minutes to reach our destinations. Buckle in as you are about to see some of the most remarkable space objects we call our neighbors. Luyten star. Let's begin our journey. After traveling the distance of 12 light-years away from our Sun, we reach a star called Luyten star, or GJ 273. Luyten star is a red dwarf, which also cannot be seen from Earth with the naked eye. It has a radius 3 times smaller than the Sun and a mass of 25% that of the Sun. Its luminosity is 435 times less than the Sun as well, so it's pretty dim. What sets Luyten star apart from other red dwarfs near us is its extraordinarily large planetary systems. There are 4 objects orbiting this small star. 2 of these objects are exoplanets, while the other 2 are still awaiting confirmation about their status. The first exoplanet we will look at is Luyten b. Luyten b is bigger than Earth, with a 35% greater radius and a mass of 2.89 times that of our planet. It is also 0.1 AU away from its star, putting it in the habitable zone of the system. Luyten b receives nearly as much light as Earth and has an equilibrium surface temperature between -14 degrees Celsius and +19 degrees Celsius. All things considered, it is possible for life to exist on this planet. The second planet in the Luytens is Luyten c. Unlike Luyten b, Luyten c is most likely a very hot, inhospitable exoplanet. It lies much closer to its Sun, and its orbit is thought to be only 4.7 days. Although its mass is estimated to be similar to Earth's, Luyten c most likely lacks an atmosphere. In 2019, astronomers discovered the remaining 2 known bodies orbiting Luyten star. It is estimated that both these objects are ice giants. Astronomers also think that they have 5 to 15 times the mass of Earth, but relatively little is known other than that as of now. We can, however, assume that since these 2 objects orbit their star within 0.8 AU, they probably lie outside the habitable zone and have freezing surface temperatures. Ross, 128. As we go past the Proxima Centauri, we reach Ross 128, which is the 12th closest stellar system to our solar system. The distance from our solar system to Ross 128 is 11 light-years. This dim red dwarf cannot be seen from here on Earth with the naked eye. That's because its luminosity is too low at around 300 times less than the Sun's. Also, it is small. It has a mass of around 17% that of our Sun's, with a radius measuring just around 0.2 that of our Sun. Ross 128's temperature is 3,192 Kelvin, twice as low as our Sun's temperature. However, Ross 128 is a quiet star which rarely flares and has a stable luminosity. But it is not the star itself that's so unique. Rather, it is the exoplanet called Ross 128b that orbits it, which has captured the attention of astronomers around the world. Ross 128b is one of the closest Earth-like exoplanets to our solar system. Its radius has yet to be measured accurately, but based on estimations, this exoplanet has 35% more mass and a 10% bigger diameter than Earth. That is if it has a composition similar to our home planet. We can also estimate the free-fall acceleration on its surface to be 12% higher than Earth's. Also, Ross 128b has a surprisingly moderate temperature range of -60 degrees Celsius to +21 degrees Celsius. That is quite unlike Proxima Centauri b, which is closer to our solar system but colder. If Ross 128b's surface is identical to our planet's, it will absorb 70% of the light it receives and have an equilibrium temperature of around 7 degrees Celsius. That is 8 degrees C cooler than Earth, but enough to sustain life. If these estimations turn out to be true, then Ross 128b is very much similar to Earth, perhaps similar enough to be colonized. We also know that the whole of Ross 128's stellar system is moving towards Earth rapidly. In 79,000 years, it will be closer to us than Proxima Centauri. As is common in exoplanets, Ross 128b is close to its star at a distance of only 0.05 AU. That's 20 times closer than Earth and the Sun. The Earth-like planet also completes a full orbit around its star in a bit less than 10 days. Unlike Earth, though, it is thought that Ross 128b is tidally locked to its star, a truly fascinating stellar system. Fomalhaut now. We will take our longest journey yet. 25 light-years away from our planet lies the Fomalhaut system. This system consists of not one but 3 stars. It was only in 2013 that we discovered that these 3 stars are gravity-bound, making Fomalhaut one of the widest multi-star systems close to us. The distance between 2 of its components can go as far as 3.2 light-years. The largest component in this system is Fomalhaut A. Fomalhaut A is a young star, only 400 to 480 million years old. It boasts a 92% bigger mass than our Sun, and its radius is 1.82 times our Sun. Fomalhaut is very bright, with a luminosity of 16 times that of our Sun and a temperature of 8,500 kelvins. Fomalhaut A is expected to go supernova and turn into a white dwarf once it reaches the age of around 1 billion years. A disk of gas and dust surrounds the star. The inner radius of this disk spans 133 AU, and its width is 25 AU. Astronomers think this disk is an active stellar nursery where celestial bodies are born. For a long time, astronomers thought there was a large planet orbiting this star, but none could be confirmed. The second component of the system, Fomalhaut B, is 0.9 light-years away from the main component. It is an orange dwarf star with a mass that's 70% of our Sun and a radius that's 63% of our Sun. Its luminosity is pretty low, being 5 times less than our Sun. Its temperature is not too high either, going up to only 4,700 Kelvin. A celestial body up to 1.9 Jupiter masses in size is thought to orbit Fomalhaut B, but more observation is needed to confirm its existence. LP 87610 is the third star in the Fomalhaut system, 2.5 light-years away from the main component. It is a red dwarf with a mass less than 5 times of our Sun. Its temperature is 3,100 Kelvin, with no observed planets orbiting around it. It is estimated that LP 87610 has only completed 22 orbits around Fomalhaut since its conception. Altair. Our next destination is Altair, a very unique star located 16.8 light-years away from our solar system. Altair is a white-blue star, and it is 11 times more luminous than our Sun. Also, its mass is 1.8 times of our Sun, and its age is 1.2 billion years. For a star, Altair rotates very fast. It completes one rotation around its axis in just around 9 hours. At its equator, the speed of its star matter goes up to 286 kilometers per second. Altair spins so fast that even its shape is distorted. Its equatorial diameter is larger than the distance between its 2 poles by 22%. Since its shape is so distorted, Altair has varying luminosity and temperatures across its surface, with the poles being darker and hotter, while areas on the equator being darker and colder. The wonder does not stop there, though. Altair does not have any observed planets, but there are clouds of gas that surround and cover the star. As the light from the star pierces these clouds, it creates a colorful rainbow-like look. This phenomenon does, however, hinder our observation of Altair, Arcturus. After traveling 37.3 light-years, we reach our last stellar system, Arcturus. Arcturus is very bright, as it emits 170 times the luminosity of our Sun. It is the fourth brightest star in the night sky, and the brightest in the northern hemisphere. But its surface temperature only reaches 4,251 kelvins. Arcturus is a star nearing its end. Its mass is 10% bigger than our Sun, but now that it has depleted its stellar fuel, it is expanding and has turned into an orange giant. Its radius is now 25 times that of our Sun. The same fate is expected to befall our Sun billions of years from now. Arcturus is thought to be around 6 to 8.5 billion years old, and it will go into supernova soon in astronomical time. Then this orange giant will turn into a white dwarf and slowly lose its heat. The Arcturus system has another component. This component is a second star that is too small and dim compared to Arcturus to be observed properly. We haven't yet found any planets in this system, so these stars might be wandering the expanses of space quite alone, slowly dying. We would like to thank you for watching our video. We hope you enjoyed it and learned something new about the stars that we call our neighbors. We'd love to hear your thoughts and questions, so feel free to share them with us in the comments section below. Be sure to hit the like and subscribe buttons to see more content like this in the future.